Now that you've seen the basics of ggplot, let's talk about creating publication quality figures in more detail. It's important to know the difference between raster and vector-based formats. Raster files are the preferred choice for photographs. They're composed of pixels, and because of this, it gets grainy when you zoom in at high resolutions. The raster formats are the formats of JPEGs, PNG, or TIFF files. And PNG is often a preferred format when you're submitting articles for publication. Vector-based graphics are the preferred choice for plots and line drawings because it provides infinite scaling so you can zoom in on those files without losing any resolution. So if you zoom in on a PDF file, you'll notice that the letters don't get grainy. Let's see an example of saving our ggplot in different file formats using different extensions. So let's work with a different data set. I'm going to copy and paste from our canvas. And in order to read this kind of file, use this function, I need a library called readr. If you haven't installed it, go ahead and use the install.packages function, and then you can use the call it with the library function. And I'm going to read that, and the first thing we want to do is look at the data. So similar to our acacia object, this was for one acacia species in this herbivore exclusion experiment in Kenya, but our trees contains all other species as well. So it has similar columns as well as the height and circumference that we're interested in. Let's build our ggplot using our trees data, and let's map for our aesthetics those height and circumference, and let's create a scatter plot using the geom point. Okay, and we can see how circumference scales with height. And let's see an example of our GG save. Let's call this acacia size scaling, and we can use the different formats. PNG, I'm going to copy and paste this to change the extensions. Let's compare PNG with SVG and PDF. I'm going to run these, and I'm getting that message that it's saving as a 3.78 by 2.24 inch image because that's the size of my graphics device here. We can modify that. And I also get a message of how many rows contain missing values and so weren't plotted. Now, if we open these different figures, let's look at the JPEG. And does it come up? Yeah, it comes up, and I'm going to zoom in. And you can see it gets a little grainy. Let's compare this with our PDF. And we can zoom in, and you can see that it does not get grainy. So that's the difference between raster and vector. So let me close this and get back here. So you can see the differences in the zoom, and some journals will require you to submit vector plots in a raster format. So now that we've seen the different formats, let's look at the different resolution, DPI, and dimensions. So let's save this figure. I need parentheses, I need quotations, figures, acacia size scaling. Let's do PNG, and let's specify this time height and width equals 10, and see how that changes the size. As you see, the size is a lot bigger, and so the axes labels are a little smaller. Let's modify the resolution. The resolution determines how many pixels occur per unit area within those dimensions, within height of 7, width of 10. And we can include that using DPI. A lot of journals will request at least a 300 DPI resolution. So let's compare this PNG resolution. Okay, pretty good. I can zoom in. Looks okay. Now let's change it to DPI of 30. I'm going to overwrite the file. And now let's zoom in, and we can see it's already grainy. So let's change that back to 300. We can also modify the different color palettes, and it's important to choose colors that work well for everyone, especially people with different kinds of color blindness and people who might print your paper out with in black and white, so maybe they don't have a color printer. But it still needs to be correctly interpreted, even if it's black and white. Viridis is a new color scale that is designed to provide a good set of default colors for addressing all of these concerns. So being good, if there are viewers who have different kinds of color blindness, and also if it's created in color but printed in black and white. Let's see. I'm going to copy and paste our scatter plot, but I'm going to change the scale, color, and you can see all the different options. And I'm going to use the D version. You can see the different versions. I'm going to run this. And I actually didn't set a color, so I need to set a color as species. And so you can see the different species there in the legend, as well as here. We can, the scale color, Viridis has different options, like magma. And so it's more of a red tones. And if we wanted maybe the color instead of by species, maybe by height. And we get this error, continuous values applied to discrete scale. So that was the D at the end. And so because color, our species was discrete, we had to use the discrete option, but now color is continuous, so we use the continuous option, which is the C. So now we have this extra visual where height increases in towards this red-orange spectrum with increasing height. Let's look at customizing the themes. Oh, before we saw theme classic, let's look at that again. And if you type in theme, you can see the different options. So theme minimal, theme void. Let's look at theme Classic. And what I like about removing that gray background is it's a little distracting to the eye, right? Design theory says remove everything that is absolutely not necessary to understanding the data. And so now the focus is on the data points themselves. And there's a really nice website linked in our Canvas as well as in our YouTube description below of the different theme examples. As you get into more complex ggplot graphics, you may want to save and export multiple plots. To save plots to work with, you can assign them to a variable. So let's assign this to species scaling. And let's change our color back to species. And instead of printing the plot in our plot window, it's stored in this object called species scaling. So if we wanted to print that plot, we would have to call that object name. And again, I got that error that discrete value supplied to continuous scale is because I changed the color to species. This is our grouping, and species is discrete, so I needed to use the discrete option for our scale. Now if I call the object name, it should show up in our plot window. And maybe I'm ready to save. So I can save that as species scaling.jpg. And I need to specify that the object is our species scaling. Let's see an example of how you combine multiple plots. Often you'll want to combine multiple distinct plots into a single figure. Maybe you have different panels like panel A and panel B. Two popular packages for this are Patchwork and CowPlot. So combine plots using Patchwork and CowPlot. Patchwork is not on CRAN, so it's been developed by someone and it's stored on a GitHub site, and so we need to install. It's in development, so we need to install this DevTools package. So go ahead and run that. I think I've already installed it, so I'm not going to run that line. And then we'll call DevTools. No, I didn't actually install it. So go ahead and install it. And then I'll run the library itself. And this library DevTools allows us to download packages from GitHub sites. And it might take a minute. All right, and I'm ready to call DevTools, which again allows us to install packages from a variety of sources, including GitHub, which is one of the major hubs of developing software. So now we can call the function install GitHub, and we want to call Thomas P85 Patchwork. All right, might take a minute, and I got this message, a warning that I needed to update packages. You can select all. Sometimes that doesn't work, so you can hit enter to create an empty line to skip the updates. There might be a little incompatibility, so if you get errors that you can't solve when using the patchwork, you might need to try to reinstall. So let's look at an example. Let's call library patchwork. Patchwork works by adding plots to one another. So let's create a plot and save it in this object called height dist. Oh, we're going to look at the distribution of heights in our trees. So we want to give it the aesthetics x equals height, and we want to fill our histogram by species. And we want a histogram, so we use geom histogram. And we want to scale, fill, viridis, and our fill is discrete, so we need to use the D option. And notice, again, it doesn't print anything when we save it in an object. If we want to view it, we need to call that object name. All right, so that's interesting. And we see the different distribution of heights by species. And we can call the different plots. Remember, we saved our first plot species scaling. Let's do species scaling and height dist. And now, because they're so big, we can't see the actual plots. So we need to use the zoom to scale. And again, we would have to go back to our individual ggplots for each of these plots if we want to specify, a different theme, different axes labels, and other layers that we wanted to customize. We can control the position of subplots using this plot layout and specifying the number of columns. And I'll zoom in. So now there's one column, whereas before there were two columns side by side. Or maybe we want to specify the different heights. So we want one column, but we want the heights to be, we want 3 and 1. Let's look how that changes the plot. So this is a 3 to 1, right? So this is 3 times taller than the bottom plot, right? So top plot, bottom plot. We can also add labeling using plot annotation and tag levels. Let's use the letter. And so it'll add uppercase letter to each of the plots. And I'd have to zoom to make it so you can see the full effect. By combining plots, this can result in fairly complex figures for publication with a small amount of code. Let's see height dist. Let's modify height dist. Actually, instead of modifying it there, let's modify it here by modifying the theme. So let's try another theme like void. And let's try modifying the legend.position equals none. Oops. There we go. So let's try this again. So now I've overwritten my height dist, and now let's see how those changes were applied. All right, so the theme void takes away all of the axes labels, the lines, the tick marks, and the labels themselves, and the legend.position none removes the legend. So now we're seeing the histogram of the different species. And if we wanted to, we should change the magma so that our scale viridis is the same color, and option equals magma. I'm going to copy and paste that into our height and run everything again so they have the same color. So now you only need one legend, and you can see the different distributions. Pretty handy. All right, so you've seen ggplot basics as well as some of the more advanced options and layers for creating publication quality graphs. I can't wait to see how you apply these to your own work and get creative with the different theme options, the different color options, and I'll link to websites that go into more detail on all these different options.